Algebra students. Here we are continuing our series on solving quadratic equations. And today we have a really big one to cover, one that you could use for any quadratic equation, and that is solving using the quadratic formula. A really handy tool that you use throughout your careers in math, science applications, etc., wherever that quadratic shows up. So just a quick recap. Our main methods for solving a quadratic are solve by factoring. This is always the easiest. If you can, factor your quadratic, set each factor to 0 and solve for your x. Solve by the square root property. If you have it set up where you could just take the square root of both sides, that's the easiest. And solve by completing the square. Typically you do this when you're asked. It does have some handy applications for graphing, but usually you want to avoid trying to complete the square just to solve. So do this when you're asked or if you're doing graphing applications. And typically any quadratic can be solved using the quadratic formula. So if you can't factor it, by default you solve it using the quadratic formula. And when it's set up in a certain format, you could use the square root property. So just giving you a little recap on that. So a big idea here is that any quadratic equation can be solved using the quadratic formula. Okay, so these are one of those formulas that you have to know. And of course, as you practice solving quadratic equations, you'll be writing it down, and that really helps put in the memory banks. Every once in a while you might forget where the sign is, you can look it up. But this is one that algebra students worldwide have had to remember. So let's get to know that. So any quadratic equation can be solved using the quadratic formula. To solve quadratic, to solve using the quadratic formula, your quadratic must be in standard form. So your equation must be in standard form. I'm skipping some letters. Standard or general form. Okay, the main format we use for quadratics, which is the ax squared plus bx plus c equals 0 format. So to use your quadratic formula, you have to have it in this ax squared plus bx plus c equals 0 format. Okay, so really important detail. And then what you have to recognize is that you're going to have different scenarios for your solutions. So what you want to note is you will have your solution types . Your solutions possible will be 2 real solutions or 1 real solutions and or 2 non-real or complex solutions. Okay? So you're going to have 3 different possibilities when you actually solve them. And since a quadratic is to the second power, that means you're always going to have, excuse my circling here, you always have up to the highest exponent. You have up to 2 solutions. Okay, so what is our formula? We're going to write this on the side here. So our quadratic formula is, I might have to give ourselves a little more space here. Here is our formula. And we'll keep it up to reference. formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Where, again, a is not equal to 0, otherwise it won't be a quadratic, and ABC taken from their standard form. Okay. So here's the formula we want to apply. And the idea is to identify your A, your B, and your C correctly. So once you have it in standard form, you identify your A, B, and C, and then you just substitute those A, B, C's in here, and you simplify. Okay? So the way you use it is to first you want to make sure your quadratic is going to be in standard form. Next, what you want to do is you identify A, B, and C. And then third, you're going to substitute A, B, and C values in the formula. And then fourth, what we're going to do, and this is really the tedious step, is make sure you substitute correctly and then that you simplify. Reduce to get solutions. Your real goal is to solve those, okay? And my tip on substituting is to use parentheses. So that way you keep track of all your positive and negative signs. Okay, so as with anything, let's go ahead and start some examples. So here's some examples. And I'm only going to do 3 today, and then you can practice more. Some examples would be, let's start with the directions solve. So in typical problems, you'll be asked to solve. If you just asked to solve, you have a choice of which method you use. So in our case, we're going to go ahead and specify, we're going to make sure that you use a quadratic formula. So you're going to solve by using or applying the quadratic formula. Okay, solve by using or applying the quadratic formula. So let's see. The first example I'm going to do, we're going to start with something that's a little simple and work our way up. Let's go ahead and do x squared minus 6x plus 8 equals 0. And we'll walk through the steps. So your first step is, okay, is it in standard form? Ask yourself if it is. Is it in standard form? Yeah. Second, identify what your A, B, and C are. A is 1, B is minus 6, and then C is 8. Okay, and I can only identify A, B, and C correctly after it is in standard form. Now my third step is to sub into your formula. Okay, so we're going to sub that into our formula, and this step will be, I'll write the formula down. And always make sure you have transcribed the formula correctly or remembered it correctly. You don't want to lose signs on something that simple. Now, what we want to do is go ahead and sub these into the formula. So with parentheses, my b is a -6. So I put -6 in place of b. I sub it in place of b with parentheses, and I say plus or minus. And again, the plus or minus in the quadratic formula comes from the fact that you could have up to 2 solutions. So you'll get whatever value you have here plus whatever this value is, and you'll get whatever value you have here minus whatever that value is. So we need to carry that plus or minus all the way down because it will help us form our final solution at the end. So plus or minus b squared, which is -6 squared, minus 4 times 1 times 8, all over 2 times 1. Okay, so everything's subbed in correctly. I'm just double checking. Looks like I got all my signs. Next step is to simplify this. So let's see how far we could go with this. We have x equals, that could be simplified to 6 plus or minus. And here we have 36 minus 32 over 2. Okay. And I could go a little further with this. I could say, of course I want to go much further. I could see that I could simplify this, and then it's a matter of how far can I go in reducing it and applying my rules of radicals as far as simplifying goes. X equals 6 plus or minus the square root of 4 over 2. And it looks like I'm running out of space. So let's move over on this side. I have to keep within camera range. Okay. So now we have x equals 6 plus or minus 2 over 2. Okay, that's what the square root of 4 is. So if we go all the way from what I have here to here, it's my next step. Okay, and then I can write this. This means 2 different solutions. So this means one of my solutions will be x equals 6 plus 2 over 2, and my other solution will be x equals 6 minus 2 over 2. And it looks like I could reduce that further. I could go ahead and find the solution here to be 8 over 2. So one of my solutions is x equals 4, and my other solution is x equals 4 over 2, which is x equals 2. So I have my 2 solutions found using the quadratic formula. If you notice this problem, you could easily solve it by factoring. But some challenges, if we all of a sudden added a minus here for the 8, we couldn't solve it by factoring, and we'd have no other choice but to solve it with the quadratic formula. So try this out. Make sure that you have this perfected. The nice thing is, if you can solve by factoring, you can verify it with the quadratic formula or vice versa. It's always nice when you have more than one method you could apply. Okay, so next example. Let's do another one. Erase all of this. Give ourselves good working space room. Always the advice of doing math. I tend to make my errors when I try to squish too much on a piece of paper or on board space. Okay, example number 2. Okay, example number 2 we're going to do is 3x squared minus 2x equals 1. Okay, so what do we do here? Well, we have to first put it in standard form. Okay, so it's not in standard form, so I'm going to rewrite this as 3x squared minus 2x minus 1 equals 0. Okay, so I have it in standard form. Number 2, I want to identify my a, b, and c. A equals 3, b equals minus 2, c equals minus 1 here. Okay, great. So my third step now is to sub into the quadratic formula. Okay, so once I've identified A, B, and C, then I carefully want to put it in this x equals minus b plus or minus the square root of b squared minus 4ac over 2a. If you recite that enough times, you'll probably have it ingrained in your brain. Okay, so here we have x equals negative 2 plus or minus negative 2 squared minus 4 times 3 times negative 1. So you can see my substitution for b, my substitution for a, my substitution for c, and this is all over 2 times a, which is 3. So just to clarify, you can see that. And this is why parentheses are really important, because when you have more than one negative, they tend to get lost in the shuffle. And most of the errors I see come from incorrectly substituting those. So you can see all that. Okay, so first just worry about substituting. Don't try to do too many steps at once. Okay, next step is to, let's finally simplify this. Whoops, my simplify is a little squished. Simplify and then get your correct solutions. So to simplify this, we would say, okay, now I have x equals 2 plus or minus the square root of minus 2 plus 12 over 6. Okay, double checking everything. Positive 2 minus 2 looks like plus 12 there. A is 3. B is 2. Oh, wait a minute. This is 2 squared. Excuse me. So this is why double checking is good. So I caught my own. This should be 16 right here. Good. So here we have our substitution. Correct, correct, correct. Good. Okay, so this gives me 4 plus 12. And looks like everything else is good. Next step is we know we can simplify this further, so you're never done simplifying until you get it as simple as can be. Okay. That's our step there. Lucky for me, I could take the square root of 16, and I get the square root of 16 is 4. So now I have my 2 solutions again. X equals 2 plus 4 over 6, and x equals 2 minus 4 over 6. And these 2 solutions will be x equals 6 over 6. So x equals 1. And my other solution is x equals negative 2 over 6. And that gives me x equals negative 1/3. Okay? 6 over 6 minus 2 over 6. So I'm doing a double check in my head, and these are my solutions. I have 2 real solutions here, as I did in the last example. Okay, so some of these problems can get pretty messy quickly. So let's go ahead and do one more. Maybe 1 or 2 more. I like to try to give you All right, let's look at a third example here of a quadratic. Sometimes we might not have so wonderful roots, things that are not perfect roots. So let's go ahead and try this one. Let's first look for the fact first let's check to see whether it's in standard form or not. So it's not, so what we have to do is readjust this. Let's move everything on one side, get 0 on the other. And when we have it in standard form finally, we could identify A to be 2, B to be minus 4, and C to be 1 correctly. and sub all those values into our quadratic formula. So A, B, C, and now I want to put those values in to x equals negative b plus or minus b squared minus 4ac all over 2a. So I'm first just writing down my formula so I could do my substitutions correctly. So the next step is to, in parentheses, I put in negative 4 for b plus or minus negative 4 squared for b minus 4 times 2 times 1 all over 2 times 2. Okay. Next step is x equals 4 plus or minus 16 minus 8 all over 4. So I'm just double checking, making sure everything looks good for substitutions, and it does. Okay. Now we want to simplify, so that's our third step that I've already started on. Oh, sub, and then simplify. Getting ahead of myself there. Okay, so we've done that. We can see we have a few more steps to simplify. You keep going until you have no other operations you could apply or simplification processes. This becomes 8 under the square root sign. So now I look at this and I have to say, okay, I'm stuck with an 8 under my square root. What I need to do is to see, since 8 is not a perfect square, I need to see if there's any factors of 8 that are. So I need to reduce and simplify any roots I end up with. So it's not going to be a nice clean number like my previous two examples, but here we can reduce this from our rules of simplifying radicals, and I can break this down into a 4 times 2 for which a factor of 8 is a perfect square, and I can pull that out. I could go ahead and take that factor out because it is a perfect square. All this is over 4. So giving myself a little extra room here, I end up with x equals 4 plus or minus, this becomes the square root of 4 times the square root of 2, which is just going to be 2 square roots of 2 all over 4. And it seems like I'm almost done here. But if you look at this, you notice that your 3 terms each has an extra factor of 2. So my simplification process is not quite done. I've simplified my radical, but now I notice I have to reduce. And the way I do that is by dividing out a factor of 2 from each term. So you got to make sure when you reduce this that it fits into each, that you can divide each 3 of these terms by that value. So my last step finally gets me to, well, I'm not sure if it's my last step yet. I might be jumping ahead. It's going to be 2 plus or minus the square root of 2 over 2. Okay. And if you look at that, that is as far as you can go. There's no other excess factors that you could take out. That is your solution. So you can leave your solution like this, or since we recognize the plus or minus as being like 2 distinct solutions, we could say one of your solutions is going to be x equals 2 plus the square root of 2 over 2, and the other solution will be x equals, make sure that we stay within the camera, x equals 2 minus the square root of 2 over 2. And if you think about what the approximate values are, this is about 1.4 if you check on your calculator, so this is about 2 plus 1.4 over 2. So x is approximately 3.14, this is about 1.41, so plus 2 is about 3.41 divided by 2. So you could get an approximate value out of that, which would be about 1.7. Okay? The other value is approximately 2 minus 1.41. So now we're looking at about 0.6 divided by 2, or 0.59 divided by 2, which is about 0.3. So these are your approximate values. You could, you know, if you need to round off and get an estimate, that works. But these are the exact values. Okay. And what we see are they're real numbers. They're just not rational numbers. They're not nice numbers. So we have square roots involved. But when we apply these to like finding x-intercepts on graphs, it's very helpful to have an estimate to know where approximately it will cross on the x-axis. So that's going to come up later in our graphing applications. So one more note before I leave off on this example. What you want to think about is what happens if you're left with a negative 8 underneath there? Well, you reduce it the same way. The only difference is the negative will be an I, and you'd have an I value here. You'd have 2 plus or minus I square roots of 2 over 2. You just write it in complex form, and that would mean that you'd have 2 complex or non-real solutions instead of real. All right, thank you. So keep practicing.